Hey everybody, this is Scott Sutherland, and today I'm going to be talking about PowerUpSQL. I was lucky enough to get to go out to Blackhat Arsenal with Antti Rantasari this year and talk about the toolkit. And so for those who missed it, or those who wanted some more information, I'm just kind of going to be going over the same deck and the same kind of demo videos we use there, in the hope to kind of answer some of those follow-up questions. If you kind of go through this and you still have things that are left unanswered, feel free to kind of reach out over Twitter. My handle is @_nullbind. Otherwise, if you have a specific bug or something like that, do feel free to submit to the GitHub repo, which is down there at the bottom, off of the NetsBy top-level repo. For those of you who maybe aren't familiar with me at all, I've been a pen tester for about 10 years. I started doing application pen testing, but for the last while now, I've been doing network level penetration testing. And one of the things, I noticed over time, both on the app side and on the network side, is that SQL is a very, very common platform. So it lives behind a lot of web applications. It lives behind a lot of desktop applications. And so it became this really great target to kind of go after. And so that's what we're going to cover off on a little bit today. I started off, writing onesie, twosie SQL Server attack tools and realized I really did need a broader framework. Antti Rantasari has kind of my partner in crime for the most of this journey. We've presented a few times on SQL Server topics at other conferences. But this was our first time presenting at Blackhat, so it was pretty exciting. Antti has done a lot of kind of open source work as well. One of the more popular repos he has is it's a web shell called SQL CMD. So if you really like web shelling, go check that out. Him and I have also worked together, contributing to a number of community projects like Metasploit, as well as DBA Tools, which is a really, really neat PowerShell toolkit for real DBA admins, but it has a lot of neat functionality that is kind of useful on the offensive side as well. So what I'll cover today is kind of listed above there. I'll give a brief overview what the tool is, what the project goals are. We'll talk about some SQL Server security basics, just to kind of lay down some foundational concepts for those who aren't as familiar with SQL Server. And then we'll try to follow some videos and overviews of a standard workflow against SQL Server. So, how do I find them? How do I get an initial foothold? How do I avoid detection while I'm attacking it during post-exploitation? And then, of course, how do I find data and get it out? So I'll be talking about all of those things as we step through. All right. So a lot of people ask, why would you spend so much time on SQL Server specifically? I kind of mentioned earlier that I do see it quite a bit during all kinds of different application and network penetration tests. So part of it is just it has so much market coverage. But also, it is very tightly integrated into the operating system, the Windows operating system and Active Directory environments, in a way that a lot of database platforms aren't. MySQL, Postgres, even Oracle don't quite out of the box have a lot of the same ties that SQL Server does, probably for obvious reasons. But it really does give us a really nice means, not just to get access to data, but also to leverage SQL Server as a means to escalate our privileges within an Active Directory domain or on a local system. So that was a very powerful kind of motivator for us. And then also, SQL Server integrates with a ton of different services and tools. So there's some opportunity for lateral movement that maybe mirror other database platforms, but were a lot easier to implement natively through .NET. So speaking of that, the next question that's common is, why did you choose PowerShell instead of Python or Ruby or some of the other more common languages that most folks use these days? I think, it's native to Windows. It's definitely become a trend in hacker tools to leverage PowerShell because it runs on every system without having to load any type of runtime. I don't have to necessarily compile everything, and it's pretty flexible. So, I think most people use it to run .NET code, but of course .NET code can run unmanaged code. So at that point, you can really do anything you can imagine, right? Any code you can write in C++, or otherwise you can pretty much then execute through this medium. So it's really nice that way. A lot of EDR solutions, antivirus, whitelisting solutions already have it kind of marked as trusted. That's slowly changing. We've kind of seen that during adversarial simulations a little bit more. Detective controls and SOC teams are getting better at detecting malicious behavior related to PowerShell, but it's still a very flexible medium, and we still do have quite a bit of success without being detected. All right, so the problem we're solving, we kind of talked about this. There's some SQL Server attack tools out there. There's definitely some good work by, like Carlos Perez did a couple cool, config reviews, kind of like plugins for Metasploit. But I think what we wanted was, the ability to really take those and exploit them. And what we found is that, a lot of the real world exploits require a little bit of DBA knowledge. You kind of have to know what configurations have to be turned on and off and what the dependencies are to get the escalation to work. And so part of the goal here was just to make it a little bit easier for folks like myself when I started out to get a handle on what these weak configurations are and actually leverage them during a pen test, which might only last a week or 2 weeks, right? The other reason or the other problem we're kind of solving is, aside from the pen tester perspective, there are a lot of DevOps guys out there and girls, women out there who are responsible for the database layer and the app layer. And, they're not really DBAs. And so they still want to do the right thing. They still want to lock down their configuration, but maybe don't have that knowledge. And one thing I thought was really cool was this tool called PowerUp, which is the original PowerUp tool written in PowerShell as well by Will Schroeder. And its goal in life was kind of to audit Windows builds, workstation servers, and allow you to identify configuration weaknesses that could be used for attacks, and then also leverage those to, maybe go from a normal user to an admin or local system. And so I really wanted to bring that idea over to the kind of SQL Server platform. And so naturally the conclusion there is, let's make a cool tool that people, pen testers and, more DevOps people can use to quickly audit and understand the risk to the platform. So Auntie and I kind of started on the journey with PowerUpSQL. A big shout out to Kai Tran also, who was with us working at NetSpy at the time. And he gave some really great feedback for the framework as we were starting off a few years ago. So let's start off with kind of functional goals. Once again, you come into an environment as a pen tester, you've never seen the environment before. So you really want to have the ability to blindly discover SQL servers through a number of different techniques. And so I'll talk about those a little later, but that was the first step in kind of the, offensive kill chain, if you will. Next, we want to be able to quickly inventory them. So kind of fingerprint them, understand what the versions are, if we can authenticate to them, pull down the server configurations so we can start analyzing those for configuration weaknesses. And then also have artifacts that we can analyze offline, maybe during the reporting phase. I also created some specific audit functions, right, so that we can kind of do kind of a read-only list of those things that are higher risk within the configuration. And then also, we're pen testers, so we want the ability to go from, a least privileged SQL user up to kind of what equates to a DBA role, and then down into the OS level. So we'll walk through some of those as time goes on here. So those are the things we really wanted to get out of it, but I also had a few other things in mind. I wanted to make sure that, we could run this on a number of different servers at one time. So we're doing that through run spaces right now. A lot of people in the community gave me good advice on that. I think, doing it natively in C# or in something like Go has proven to be a lot faster. We'll see if we're going to port PowerUpSQL down the road, but right now, still a PowerShell framework, so you can get a little bit more mileage and reduce the time with those run spaces, which kind of run behind the scenes. The other thing is flexibility. One of the coolest things about PowerShell is that you can pipe commands together. So you can run one command, and the output of that command can be fed directly into another. So you could, pipe dozens of commands if you really wanted to, but if you write your commands correctly, you shouldn't have to use that many. But anyways, as we'll see later, you kind of land in one-liner heaven. So you don't have to run, 15 commands, parse the data, glue it all together, and then run another tool. That's something that was driving me nuts prior to building this. And so I wanted to make sure other people didn't have to go through that pain. The last major kind of project goal was portability. The SQL Server support has been in .NET Framework since version 2.0, so we're pulling directly from there. So it's native. It should run on pretty much every version since, I think, Windows 7. I think most of it's 2.0 compliant. We did want it to run on Windows 7 without breaking. I think there might be a couple functions that require a newer version. Those would be some of the new C2 functions, but for the most part, all the core functionality can run on 2.0. The other thing is when you install SQL Server, you get a set of DLLs, and those DLLs are typically what SQL Server programmers will wrap in order to do whatever they need to do. But those are technically licensed by Microsoft. And so I didn't want to have to kind of illegally carry those around with me on my pen test. And so for that reason, I just coded around, the .NET framework libraries that are going to be everywhere, as opposed to using the SMO. So that's kind of my logic for that. But it really is a fast medium. I think DBA Tools, which is a little bit more of a legitimate tool for DBAs, wraps some of that. And of course, they write some of their own libraries as well. So if you're looking for something that's kind of built that way, go check out that tool. It'd be worth your time. And then lastly, I put everything in a single file. And the reasoning for that is I did want to make sure I could put it into one-liners for download and execution a little bit easier. I didn't want to have to download multiple artifacts, kind of wanted to reduce the footprint. And ultimately, if you kind of look in the file itself, it's organized into pretty natural sections. If you use some of the nice coding tools or IDEs that are available for PowerShell, it becomes pretty easy to manage. All right, so those are kind of the main goals. The PowerUpSQL wiki was something I put together maybe last year or the year before, because people kept asking me questions about commands, and I was excited about it and wanted to share that knowledge, but it became a lot of overhead to have those conversations. And so I kind of put it all in one place. So the wiki is off the GitHub repo. So if you, hopefully the recording will show this, but you go to NetSpy, then PowerUpSQL, and then the wiki tab will bring you to the GitHub wiki. And so here we have all kinds of stuff. We have this overview of what it is, kind of what those main goals are, how to download it, how to set it up in different ways. By far the most popular sections are this PowerUpSQL commands, which is the primary use cases that people use on a daily basis. And then if you do want to see the blogs, we have, I don't know, almost 20 blogs, a number of different presentation and videos from other conferences, and kind of other demos that we've done. So check that out. That's a really good starting point. If you can't find it there, please feel free to reach out to me. Sometimes I'm in the Bloodhound chat Slack as well. So. Another thing I did last year per request was create some templates. And so what I mean by that is PowerUpSQL, I took that and wrote a number of different functions so that you could very easily attack SQL Server directly without knowing a whole lot of native TSQL. But some people really did want to do that manually, and they did want to use the same concepts and maybe apply them during manual SQL injection attacks. And so I created a number of TSQL files that you can kind of go out and navigate. You can pull them down and modify them, and I've kind of tried to organize them by functional group. So there's a number here you can see. It can do OS command execution via different mediums, reading files, writing files, and things like that. So check that out. It's definitely useful for me. I still reference it during pen tests today. All right, basic setup options for those of you who are not really familiar with PowerShell or just want to know what the options are for PowerUpSQL. You can download from GitHub to the disk directly off the website, and you can run this command here to import the module. Alternatively, a lot of kind of offensive folks like to reflectively download it into memory and run it, and so that's pretty common these days. And then there's a popular alternative that came out. Apologize for not crediting this one. I think this was Matt Graber, the first instance. The second one is escaping me at the moment. Both are very handy. And then lastly, I did actually publish it to the PowerShell gallery, which is hosted by Microsoft. So you can install it very formally. And I'll be trying to keep those in sync as time goes on. They're pretty close to synced. So let me jump ahead. Let's see. Yeah, I'll come back to this. There's a number of setup options, but this is just a basic example of importing the module. You may get this warning here, and it's basically just saying that I named a few of these in such a way that they don't really match the naming convention that Microsoft prefers, but they're pretty close. I think it's all verb noun. So don't worry about that. It's not necessarily a security warning. All right, so for those who have installed it, you've gone through that setup process, and now you want to get some help. PowerShell natively supports command help, so you can run git command -module, choose PowerUpSQL, and it'll give you a list of all the available functions and the version, which you can cross-reference against the file online. Also, you can dig into a specific function with the get help and then the function name, which is very cool. I recommend using the full switch, which is actually going to give you full examples. So as I created most of these functions, I tried to create real looking examples so that you could kind of see what the expected output looks like. If I had a better screenshot, you'd see it if I scroll down, but just know that that's available. There's a number of different popular functions. Check out the wiki, just kind of go through the cheat sheets. They're going to cover the majority of these, and many of these are also within the videos section of the site. So for Blackhat, we did want to do a few new things. So at a high level here, we started working on an SQL kind of command and control, which I'll give a really brief overview of later. I added some lateral movement. So like TSQL templates, so you guys could do some manual stuff. I'll touch on that. And then some more persistent things. Also pretty new, there's some really great work done by Thomas. And he, if you check out the NetSpy blog, he's done a lot. He basically created a whole set of functions that allows you to use SQL Server to do kind of all that Active Directory domain recon through SQL Server. Via a couple different techniques. So really, really neat stuff. He put a lot of work into that. So that's worth checking out. And that's linked on the wiki as well. All right. So let's talk about some SQL Server basics, because I know not everybody is super familiar with this. At a high level, SQL Server is a database platform, right? So it's hosting data. It's a Windows application, and it runs as a set of Windows services in the background. So, I tried to create a nice little visual here, but you have the operating system and then an SQL Server instance, which is kind of a set of Windows services or a Windows service. And so you can have separate SQL Server instances on a single server if you want, and they'll be treated as kind of different database servers essentially. But under the hood, they're Windows services. I think we'll touch on this a number of times, but OS commands that are executed through SQL Server typically run as a service account. There are some exceptions to that, which we'll get into. The service account is also implicitly a sysadmin by default on every version of Windows. So that's an interesting thing. And then clustered servers are required to have a domain service account, to my knowledge. So we'll get into the impacts of that later, but I just wanted to kind of set that foundation now. Next, there are a number of different ways to authenticate the SQL Server, and there's kind of three main types of accounts. So first of all, you can have Windows accounts, so that's Active Directory or maybe even your local Windows account. That, if we look at the image on the left here, is then mapped to an SQL Server login that is sometimes automatically created, and then that is then mapped to a database user. So in order to get access to actual data in the SQL Server instance, all three of these things have to be mapped correctly, and the privilege has to be set correctly. So it sounds complicated, but we'll see some defaults that have some interesting impacts in a little bit. All right, so let's talk about finding SQL servers. So there are a number of different ways to do this. I did work with Auntie and Chrissy Lamar on DBA tool function that is a little bit more robust than what's here. But this will be immediately available if you import PowerUpSQL. This has, the ability to do UDP scanning across a, broadcast domain or across broadcast domains. There is a get SQL instance broadcast, which will basically send a broadcast out that is within your broadcast domain. So it says, hey, everybody, is anyone an SQL Server instance? And the SQL instance will say, hey, I'm over here. So that's kind of neat. We have get it from a file, so you can provide it a list. You can check locally. It will list all the local instances, or you can get it from the domain. And this is really the most powerful one. We'll be seeing this in example quite a bit as I walk through. Essentially, every time you install SQL Server on an Active Directory domain system, it registers with LDAP in order to support Kerberos authentication. And so as a kind of side product of that, or byproduct, any normal domain user will have the ability to query for an entire list of SQL servers that are kind of known to the domain controller or have these registered service principal names. So we'll see examples. It will make more sense as you see the videos. All right, so in this demo, I'm going to kind of walk you through some of the more common functionality. On the right here, we've already imported the module. And so first, we're just going to call that get SQL instance local. And so that's going to list the local SQL Server instances. You can see it gives us some display information. It tells us the instance name and what service account it's running as. In this case, it's demo app service, which is a domain account. Down here, we're running as a local service account or managed service account. So that gives you a neat idea. I also wanted to be able to show pulling down those service principal names like we talked about before. Whereas locally, you might have one or two SQL Server instances. When you go and query the domain for those SQL Server instances, in small environments, you might get a dozen or so. In large environments, I've seen thousands, but usually it's in the hundreds somewhere. So especially when you come into, Fortune 1000 companies, I'd say it's pretty common to see that. One thing to note as you walk through this, we're going to step through here. I'll outline this in a second. So what this is going to do, we're just going to run get SQL instance domain. It's immediately going to go out. And in my lab, it only found 9 instances. In real world, like I said, it can find thousands in very large environments. And so one thing to note is in those very large environments, some of those SQL instances probably have gone away, like applications have been decommissioned, servers go offline, mergers, acquisitions, and separations or spinoffs happen. And so sometimes they won't be listed anymore. One way to filter those out or attempt to filter those out is through last login. If they haven't checked in a decade or something like that, they're probably not there anymore. So just if you're trying to reduce the amount of time it takes to kind of review some of these, sometimes that can be a way to filter it. But lots of interesting information comes here. So you get, the computer name that the SQL server is installed on. You get the port or instance. So this is a port example. Over here we have the formal instance name. We get once again the domain account. In this case, it's a computer account. Down here we can see it's a domain user. When you see it's a computer account, typically that means it's installed as a managed service or local service or maybe even local system. But these are typically what you're looking for when you're attacking SQL Server, are these kind of user accounts, which are handy. Let's see here. So, yep, and the account description, which can be handy as well, especially in many environments. Companies will use a single account domain account to run many different services or SQL Server instances, I should say. And so sometimes they'll call that out right in the description. So you can use the description as an indicator, or if you're looking for shared SQL Server service accounts that are domain level, you can run this command. So what it will do is get that list of SQL Server SPNs that we talked about, and then we're going to leverage that pipe to group object. Group object is a native PowerUp function. It's going to allow us to, it's kind of like a group by. And so we can see there's 4 servers running app SVC and 3 running SQL SVC. So later on, when we're trying to attack shared services, we can come back to these guys and we know where we're going, which systems we want to attack, and which accounts are going to be kind of the focus of that attack. So really powerful stuff. Really saves a lot of time on pen test engagements. I also added a little flag here. So if you wanted to look up a specific service account as opposed to doing the counting, you could do that too. Next, in this example, we're going to show the power of kind of the piping again. We're going to be calling get SQL instance domain. It's going to pipe off to get connection test threaded. Basically, it's going to try to log into all the SQL Server instances it finds with your Windows account, and then kind of spit out the status of which ones it could do, which ones it can log into. You will notice there that on all of these, as I've been walking through, I use the verbose flag. If you don't use a verbose flag, you're not going to get all this good status information. And in large environments, it might look like some of the commands are hanging. So make sure to use that verbose flag so you're getting what you need as you walk through, at least a status. So here, the output we can see, we can access some, we can't access others. Another really neat thing about PowerShell is that you can set the output to variables. So in this case, I'm outputting all the data as a .NET data table and storing it in this targets variable. And why that's cool is I can go through, find all the SQL Server instances, and then I can attempt to log on to all of them, right? Accessible, not accessible. But I don't want to have to go through that every time. In an environment where there's thousands of server instances, it might take 10 minutes, it might take 15 minutes or something like that to iterate through all of them, even with a little bit of threading enabled here, like you see in the example. So setting it to the variable allows us to take this data set and then filter and eventually pipe it into other commands. So not just, now I know where I can log in and I want to be reusing that list of targets with other functions. So here we're assigning it to the variable. Once again, we can see that verbose output telling us what's going on. Now we're just going to kind of list what's in the variable. We filtered by accessible, so we're only going to be trying to perform actions against SQL Server instances we can log into. And then our first example here just pipes to the get SQL Server info. It's actually one of the more popular non-offensive functions. So here we're basically just getting some basic info on the servers we can log into, the computer name, the instance, what Active Directory domain they're associated with. So if it's not on the domain, it will just be the computer name. You also get the version of the OS, the version of the SQL Server, and some other interesting config info. So that alone can give you a starting point if you're trying to kind of whittle down different things. The other example I have here is get SQL database. And so this gives you a bunch of information on the databases that are on the servers you can log into. Naturally, the more access you have on that server, the more information you're going to get. In this case, we're a least privileged user, and I try to indicate it here. So if you see has DB access 0, that means we can list all this information about the database as that kind of least privileged user, but we won't be able to read the data. So if you're actually trying to pull out data, you're going to be looking for this, the has DB access 1. And we're going to get into how to scrape data very quickly later, but for now, just kind of keep that in mind. All right. Let's carry on. All right, now we're going to assume, we saw this before, we have a domain user, maybe we don't have any access. And so I want to talk briefly about how people typically get initial foothold. We saw just testing logins, and that's definitely super handy. I'll highlight that, kind of show some of that as well. But there are some other cool methods. So naturally, attempting to log in as a domain user or local user, very useful. Very commonly works for a number of reasons. Weak SQL Server login passwords for SA, things like that. That's less common these days. It used to be very, very common. We still see test, things like user. Those are still around, or dev, as in dev as a username and dev as a password. but more commonly now, we're seeing default passwords associated with third-party applications. So sometimes when third-party applications install themselves, they install the SQL Server instance, and they name that instance something that's very unique to their application. And so when I get a list of those SPNs from Active Directory, that list of SQL servers, I can look through that list of instance names, and I can say, hey, I know that this is associated with XYZ application, and that XYZ application is configured by default with this username and password combination, and then I can try to log in. So I'll show a demo of that later, but we've had some success in larger environments with that, so pretty neato Frito. All right, let's see here. One of the things that we see a lot of is that SQL Server, instances that are Express version will allow you to log in. That's usually third parties, but sometimes dev groups, very, very common. And the reason that works is because SQL Server by default, SQL Server Express by default allows the local user group to log in, and the local users group implicitly includes a group called authenticated users, which when you're attached to a domain system, when SQL Server is installed on domain system, that includes all the domain users. So that's why most domain users can log into SQL Server Express instances that live on domain systems. The other common issue is that you have these DevOps scenarios again where people are very rushed to get code out, they're very rushed to deploy applications, and so sometimes they just add the entire domain users group or give them the privilege to log in at least. So that happens as well. So here are the kind of basic breakdown. I'm not going to go into them too much here. The wiki's out there. It covers a lot of these things in the cheat sheets. So just know at a high level, we have unauthenticated perspective, local user, domain user, and then also our alternative domain user. In this case, I'm cheating a little. I'm using run as with the net only flags to basically launch PowerShell in the context of a different domain user. And so the way that will work is usually locally, because of the net only, it's not going to be running locally as that domain user, but when it communicates over the network, it will. So pretty slick. All right, these are the two functions I kind of talked about earlier, auditing for weak passwords, auditing for default passwords. I'm going to cover here auditing for weak passwords. What this is going to do, this particular one is going to log in with a kind of a least privilege SQL login. And by default, when you log into SQL Server as a public role, you don't have the rights to just select a list of all the users on the system. If you select from the users table, you only see SA, which is the default account, and your own account. And so I started reading through functions one day, kind of looking for inspiration to play around with, and found a handful of functions that allow us to basically provide a number, and it returns the username. And so we can just fuzz that number or increment that number and enumerate all of the users in that SQL Server instance. And so I added that to the invoke SQL audit weak login pdub function so that when you run it, it will find the users and then try username as password. And when we run these functions, we're actually finding in most large environments, we get a handful on most engagements, maybe, 70% of engagements where we're able to run this on a larger scale. So, and then also what I'm going to cover here is get SQL fuzz domain account. And so SQL, there's something very similar that allows us to not just get SQL logons, but if the SQL server is on a domain system, we can actually resolve full domain accounts, domain groups, and things like that too. So we'll take a look at that. I'm going to let this demo run, and I've tried to add some pop-ups so that it can highlight those ideas. So, yep, I just showed there I'm not a sysadmin. Here I'm doing some basic fuzzing. The new version uses number tables, thanks to a large community of DBAs who kind of gave me some guidance. So thank you guys for your help. And here we're going to go through that fuzzing process again. It tries some weak passwords, and that's how quick it gets through the fuzzing and spits out findings. So when you run a lot of these audit functions, anything that says invoke SQL audit and then whatever the standalone function is, you're going to get output that kind of looks like a light vulnerability report. So you'll have here weak default password, kind of says, hey, you have a password that's pretty common. You probably shouldn't use that. Give you general recommendations. Talks about severity. That's all based on my bias. Whether it's vulnerable or not based on configuration, and whether it's exploitable. So vulnerable would be like you have a weak configuration that might have dependencies, and if is exploitable is marked to yes, that means that all the dependencies are met. There's also a flag, the exploit flag, with most of the audit functions that you can run, and it will attempt to actually proactively exploit those. And here, another note for the weak passwords. If it is able to guess a username and password. It will try to determine whether it's a sysadmin or not. So that's kind of neat. So it gives you some immediate context. So you don't have to go check for yourself. I'm lazy. I like it for that reason. And that's kind of why I put it in there. All right, this one's going to do an example of the fuzzing for domain users, groups, etc. You also do get the list of computer accounts, which is kind of neat. So the way that this works is it gets that domain. There's a get domain function, essentially, with an SQL server that everybody can run. Once you know what the Active Directory domain is, then you're able to kind of infer that there's a domain admins group, because there's always a domain admins group. And then there's a similar function to what we described before, but kind of in the inverse fashion. So you can provide it a known domain group, and it will return a full RID for that object in Active Directory. And then you can just kind of chop off the last little bit of that, and then increment the RID, provide it to the other function, and away you go. Once again, the details for the TSQL are in previous DerbyCon presentations. I think that was the 2016 presentation. And then there are also TSQL examples in the templates if you want to play around with that manually. All right, so I think we ran through that. The next one here kind of highlights the third-party software, using its custom SQL Server instance. So here we're running the local instance list. We get the whole list. The one that we're actually going to be attacking got cut off, but you get the general idea. And then here we're going to be using that piping again. We're going to get our local instance list, and then we're going to check the instance names for matches. Normally, in a real pen test, I'd probably be more likely to run this on get SQL instance domain than local, but for the example, I just made it easier. Here we go. So if we scroll up, we can see the verbose output says, we started the vulnerability check, we confirmed that we know what this instance is, and then we confirmed the default credentials actually do work. They are there. So it will attempt to log in. So that's what's happening on the background to confirm that. I think right now there's about 50 instances. I would just like to say thanks. I think Rob Fuller did a project before I did this one. I think we had a little list of SQL Server instances with defaults, and he had one Pwn wiki. So we kind of smushed those together, and then I wrapped them with this code to kind of streamline it a little bit. But yeah, so that was another kind of community thing. So check out Pwn wiki too if you guys haven't already seen that. There's some other good manual info there. So as we go down, so here we can see the output, after everything runs. We can see the instance that's vulnerable. We know there's a weaker default password associated with that. And then we actually generate the PowerUpSQL command that you can run. And then you can just use that, literally copy and paste. I tried to do that with a number of these, standalone audit functions. There's kind of a higher level audit function we'll see in a bit too, but this was the first one. Yeah, so we ran that and we just got the version information via a basic query. So pretty neat. Saved some time, definitely. So once we've got that initial foothold, we talked about, just to recap that last section, we talked about guessing default passwords. We talked about using domain credentials to just try to enumerate and log into SQL servers. Then we talked about using third-party software kind of default configurations to get in. Once we've done that, we kind of want to get the lay of the land. If you're on a real red team engagement where you're trying to avoid detection, you usually want to avoid tripping alarms naturally. So I did create a couple functions for looking at the standard ways people audit. There are server audit and database audits. As the name imply, these are just going to give you a list of things that operate at the server configuration level. This is going to give you things that operate at the database level from an auditing perspective. So DDL and DML events. General guidance from me, just based on previous experience. Removing audit controls usually is not something that clients really like to see. Controls can also be kind of not something people are a super big fan of. Both removing audit controls and disabling audit controls can be a little loud. The removal or disabling themselves can result in an alert that is kind of higher suspicion than even the actions themselves that you'd be taking. So generally, try to just get a list of everything they're auditing and try to just use techniques that they're not keeping an eye on. That's kind of the summary. There's more on that. I go into that a little bit more in the DerbyCon talk from 2017 if you are interested. All right, privilege escalation. So we're going to be talking about a few different perspectives here. Let's see here. Before I dive into those, basic concepts: service accounts, sysadmins, and explicit permissions. So once again, if you're running OS commands through SQL Server, you usually have a sysadmin privilege, meaning you're a DBA, or you've been provided an explicit permission to a function that allows you to execute commands either directly or indirectly. So that's one thing to be aware of. Most command execution options run as SQL Server service account. We talked about that. The service account can be configured in a lot of different ways. By default, it's local user. If you're running a cluster, I think it has to be a domain user. But we still, to this day, occasionally find service accounts running as domain admin. So taking over an SQL server could mean you essentially took over an entire domain. In some instances, less common now, but used to be very, very common. Then last big bullet here is SQL Server service account is a sysadmin, right? So if you can impersonate it in any way, shape, or form, you're going to become a sysadmin who has access to all the data. And when people are trying to do that, become that service account, right? To become the sysadmin, there's a number of different techniques. This table kind of outlines which techniques are working or available on what version of SQL Server. I'm not going to go through them right now in depth. I have gone through them in the past on other talks, but use the slide or check out. There's other blogs that you can get off the wiki where I go into this in more detail. So, as a local administrator, sometimes you want to get sysadmin access, and surprise, just because you have domain admin doesn't mean you have sysadmin in the SQL server, right? So what I'm going to show here is leveraging a function that actually wraps Joe Bailick's invoke token manipulation. So we're basically going to steal or clone the authentication token for the SQL Server service account, and then we're going to use that to do everything we want to do and then revert back to ourselves. So I will kind of let this run. I think I have pretty pop-ups for it, so enjoy. So I'm just emphasizing that point I noted earlier. I am a domain admin, but not a sysadmin, as I've connected to SQL Server locally. Yeah, so if I didn't mention this before, you do right now, this function can only be run on the SQL Server and not remotely. But here we've gone through and impersonated using the invoke SQL impersonate service function. You can see I'm now running as a service account and I am a sysadmin, and then I can rev back to self. One thing to note is that I'll let that run while I chat, is that once you've impersonated the service account, all of the PowerUpSQL functions will now run as a sysadmin. So if you're looking to scrape data or execute, recon or install any of these CLRs that we'll talk about later, that's going to be a good way to get to that point where you have that level of flexibility. So just kind of keep that in mind. All right. So that was going from local administrator on the Windows side into the SQL Server sysadmin kind of DBA role. Now I want to talk about going from kind of a domain user or SQL login to a sysadmin. There's a lot of ways this can happen. Weak passwords we've talked about pretty extensively already. Excessive privileges to all kinds of functions that might allow you to execute with sysadmin privileges for various reasons. Startup procedures, custom store procedures, extended store procedures, all kinds of things. Once again, 2017 talk or the 2016 recon talk really goes into kind of those excessive privilege scenarios, as well as SQL injection into custom stored procedures that people have come out with. Also, out-of-date versions can kind of lead to some escalation. I did find a couple bugs that allowed UNC path injection that couldn't be prevented, but Microsoft has fixed it, I think for 2012 and up. So if you're in an environment managing databases that are of a lower version number than that, you should really think about updating those for the sake of security. Always easier said than done, though, right? All right. So I have created this invoke SQL audit function, and so when I run it here, you're going to see I'm searching for vulnerable configurations and reporting them, and then I'm going to kind of walk through how to output them in different formats, because PowerShell by default, if you are spitting out data tables, you can output it to grid view, the console, CSV, and XML, and then it can be consumed by other things pretty easily. So I'll just kind of let this one run. And then at the end here, I'll just kind of note that, aside from just viewing vulnerability data, you can also try to auto-exploit the vulnerabilities that are there. So if you use that exploit flag, it will try to find the first one that it can to get sysadmin, and then basically assign the current user that you logged in with. It will assign that account sysadmin privileges. Fair note, though, right now it doesn't automatically remove it, so you'll have to issue the query to remove that role during kind of post-exploitation cleanup. All right, so there you're seeing kind of the output going to the grid view, which can be handy for quick searches. Once again, we kind of talked earlier about taking the output of a command, any of these PowerUpSQL commands, and assigning them to a variable for reuse. So that really makes it easy to view, analyze, and kind of record this stuff offline. So you have these artifacts when you get to reporting if you're a pen tester, or remediation maybe if you're a DevOps or pseudo kind of DBA role. So cool. Big props to the PowerShell guys for baking in so much native functionality. Save me so much time. So there goes the first one. You can kind of see the XML output. So great. And that was just the audit and saving kind of the configurations. Here, we want to actually get sysadmin access. We're running as that Blackhat user. So we'll use the exploit flag, kind of go through the same general motions, but this time leveling up as it goes. Do. Almost there. The amount of time this takes obviously will, or maybe not obviously, will be dependent on kind of the number of databases. So if you're looking at a server that has 15 databases that are fairly large, it'll take a little longer. But typically we run this audit against a single server at a time versus the entire domain for the sake of safety and being more concise. But here we can see it auto-escalated us. So now the Blackhat user is sysadmin. So pretty handy. Had a lot of success. All right, so when we look at things and we've been auditing and we find UNC path injection quite a bit. There's a number of different services, native SQL Server functions that allow it. So from talking to other pen testers, this is the most common escalation path. We locate SQL servers on the domain. We attempt to log into each of them as a domain user, and then we perform the UNC path injection. So it kind of looks like this. And then usually the service account's a local administrator as well. So not only do we take over the SQL server, but we take over the operating system. And very often there are other kind of tie-ins. So here's a brief example of that. This is written by Thomas as well. Let me start this off. Thomas has done some really cool stuff. Yeah, once again, if you have a chance, go to the NetSpy blog and check out Thomas Elling's list of PowerUpSQL stuff. But also he does some neat reversing things that are worth peeking at. Yeah, so here I'm just getting my IP. I'm running as a least privileged domain user. I'm going to be basically connecting to all those, basically going to the domain, getting a list of SPNs, attempting to log into them, and then performing UNC path injection so I can either capture the password hash or relay it. In this case, we're just capturing it, but you could definitely relay it with a tool like Inve by Kevin Robertson. He's also done some new updates to that tool that give you some more variability there. So that's out on GitHub too. Another good open source project to check out. It's kind of like a PowerShell-based responder if you're familiar with the responder toolkit. So here at the end of the day, we have, well, I pressed the wrong button on that, but you get the idea. Basically, you're able to run it and very quickly capture password hashes. I actually use Inve behind the scenes to do the password hash capture as well. So that's probably the most popular use case there. Lateral movement is also something people like to do a lot of. You get in as a least privileged user and you kind of want to move around. Sometimes we can do that via shared service accounts, which typically require sysadmin rights. But the next most common is SQL Server links, which do not necessarily require sysadmin rights. So that can be very powerful escalation medium. The shared service accounts, why do we care about this? The general idea here, we've talked about kind of the first three bullets quite a bit. It's the fourth bullet that's most important there. Companies often use a single domain account to run hundreds of SQL servers, right? And that means the sysadmin can drop down and execute as that service account. That service account has sysadmin privileges on all the SQL Server instances it's running. So you can basically move between, hundreds of servers, regardless of whether they're related to the same application or not. So you might be the DBA of the marketing group, but through this privilege chain or inheritance, you might get access to the main banking app where all the kind of critical regulated data is. So one account to rule them all. That's why it matters. We've done this via SQL Server injection before, kind of coming through the web server, poking through the backend firewall because the SQL injection lands us in the database. Then, enumerating other systems that have that same account, kind of moving laterally between, like a low value application and a high value application. Historically, we've done that using techniques like this. This is a PowerUpSQL function, invoke SQL OS command, which runs XP command shell, which is kind of pretty traditional method for running OS commands through SQL Server. And it's going to call this SQL CMD binary that is automatically installed in SQL Server. There's a few different clients similar to it that come with it, but the more important thing is this -E switch here, which says run as my current user, run as my trusted connection, so that you can actually impersonate the service account and run queries against a remote server without ever needing to know the password, which is pretty powerful. You can do the same type of thing with open row set. It requires that ad hoc queries be enabled which is what I show up here. But once you have that, you can basically set trusted connection and do the same thing with TSQL without having to use XP command shell. So that's kind of a neat trick as well. I guess I said as a sysadmin, but really I believe, yeah, sysadmin or SA is what you need to happen. Otherwise, it will run as your current user. Or if you don't run as a sysadmin, you'll get access denied. So SQL Server links are very popular. We use them quite a bit on all kinds of assessments. Basically, it's a hard-coded connection between two SQL servers. So think of it as a connection string that's stored on SQL Server A, so it can authenticate and pull data from SQL Server B. Very often they're persistent and you can do queries over them even if you're not a privileged user because they're pre-configured with someone else's credentials. Sometimes that's a Windows account, sometimes that's a SQL Server login. And some of those occasionally are configured with SA privileges. So you can actually use it to go from a low privilege user to a high privilege user as you follow those links. The other really neat thing is that they can be crawled. So you can hop from SQL Server to SQL Server. Like I said, we see them about 50% of the environments. I think the max number of hops we've had is, before going into kind of recursion, is 12 hops, starting at Server A and getting all the way down to the end. And then max number, going through different crawls is, 226, something like that. So it's a pretty interesting surface of attack. And once again, we do it directly. You'll be seeing direct attacks, but you can also do it through SQL injection. Similar to the last scenario, you kind of come through the cloud, you attack the web app, you land on the database server. But this time, you don't have to be a sysadmin to follow the link. You can be a least privileged user, follow that link over if it's configured wrong, and you can kind of keep doing that. So we could go from LVA to DB1 and hop into this high-value database, and if the server link is configured with SA or a privileged account, as a pen tester, that's a good day, right? And it's going to give you some hopefully constructive things for the defending side. So also really neat, sometimes we're able to follow a path like this and actually get into an isolated PCI zone. We've done this once where we actually went through an Oracle server back into SQL Server and then landed in the PCI network. So it can be very interesting. Also, just be aware that this has the potential to hop point-to-point VPNs into other companies. Lots of people will push data over those links. So be kind of aware of the domains it's reporting back when you're running it. We started playing with the same platform that Bloodhound's using. Auntie Ranchasari actually, has an export for the function we'll see later that you can suck into the framework here and illustrate kind of the links and the privilege that they all have. So it just kind of helps visualize the network that's kind of laying underneath, Active Directory, right? This is just SQL Server to SQL Server via those types of links from this is from a real environment that we anonymized naturally. But sometimes they get much, much larger than this even. This is actually kind of a small link crawl. But let's take a look at this. So this is the original script that he wrote. If you go to the wiki right now, it has all the up-to-date commands, but this will give you the gist. Basically, it's going to crawl through. It's going to show you there kind of, every hop, what the link path is. So server 14 to the 2012 server, it's going to tell you the login name, whether it is configured with sysadmin privileges, which is handy. And then give you the general link counts that you can expect as you're going through. I think we fixed most of the recursion bugs, so it tries not to take the same paths twice. But the nice thing here is it will print out, and like I said before, you could pipe this into a variable, or I'm sorry, write it into a variable and then pipe it into a report like XML or CSV or whatever, but it will give you the information you need to then kind of take corrective action. And you can see which ones are sysadmin to see these are the highest risk items we should kind of start with. So pretty handy stuff. That's all Auntie. Auntie's passion has been those links. So that's been a really fun thing to be a part of. So this is the hour mark. So I think Arsenal is about an hour and a half, something like that. So I'm about halfway through, the topics that we touched on. Feel free to go get coffee or whatever. Hoping that I'll get through in the next half hour. So I totally understand if you can't make it. Otherwise, there's links and all kinds of stuff out on the wiki. All right, command execution. So we've talked a lot about escalation, and some of that involved command execution. I spent a lot of time for my 2017 DerbyCon talk focusing on what are a lot of the common ways we could execute commands through SQL Server. And the intent there was really to create some variability so that we could avoid detection controls, right? If someone's auditing and looking for XP command shell, what are the ways I can get around that? Before we kind of give the high-level overview of the techniques, one thing to know is, if you are executing through something like XP command shell, it's probably going to be the SQL Server service account, but there's also an SQL Server agent, which is kind of like scheduled tasks on the SQL Server level. It has its own Windows service, and so when you execute through that, the service account that it executes through can be different. Also, if you're running as a Windows user, sometimes it will just run as you, depending on how you're doing it. And then you can configure explicit credentials, which I'm not going to really go into that in this talk, but you get the general. You can get the general idea by going out to SQL servers, MSDN pages, or looking at some of the previous talks we've had in the past. Once again, OS commands via SQL Server means Windows account impersonation without having to know the password. Super handy. So there's a lot of options we built in, some PowerUpSQL functions for XP command shell. You can write extended stored procedures in C++, which are really neat. So I created some PowerUpSQL functions for creating your own, and then also getting lists of custom ones that you might want to reverse engineer during either during application assessments or NetPens. CLRs, so .NET assemblies that you can create. So I have one that the create SQL file will actually randomize all the classes and methods and namespaces and stuff, so it's a little harder to detect. And then also you can get the existing ones that are there. The really cool flag there is export folder. So when you import a .NET assembly, it actually stores the code in the database. It doesn't store it directly on the disk, which is kind of interesting because that means as an attacker, you're not dropping the DLLs on the disk, so that's really nice. But also if you're kind of reverse engineering or attacking someone's custom CLRs, you can pull those out of the database and export them back to a temp folder and start reversing those. And so I'll show some screenshots of that at least, but I did a whole blog on that topic a while back. All the automation procedures are also really neat. I have some examples of TSQL templates, but I'm barely scratching the surface on that one. I'm kind of with more traditional, I think, kind of like COM object wrappers, essentially, which are also kind of mirrored in the ActiveX, quote unquote, agent jobs you kind of see in the next row. And then so on and so forth. You can also, there's a number of options for writing to the operating system, kind of auto run locations where you drop a file, and if a user logs in or a certain event occurs on the system or within the database, then the code runs. So a lot of options. This is not a definitive list. I'm aware of that. There's like SSIS jobs and a few other things. I think you can do custom scripting, runtimes and things like that. And I haven't even began to explore those or the kind of the other non-standard add-ons to SQL Server. So that's a good starting point, though. Anyways, this is what the output looks like. If you are using some of the PowerUpSQL functions, most of them will return the command. The only blind ones, I think, are the agent jobs. But the rest of them will look at the server configuration. If it needs to be changed, it will change it, and then it will restore it when it's done. As Ati and I say, we're basically both Minnesotans, so we're kind of taught to leave the environment as we found it, and so that's what we try to do with these commands to kind of do good house cleaning, which you kind of get the idea. All right, so that was commands. Another common thing in post-exploitation is persistence, which is basically staying on the system, maintaining access to the system, either from the internal environment or from the internet. There are a lot of ways to do this. We kind of talked about the agent jobs. We haven't really talked about triggers in much depth. I have done a few blogs and released some tools on those, which are handy. Basically, if a certain event happens, then it can phone home or add a user or whatever you want. I talked to a few folks, and it sounds like it's actually been used once or twice, which is kind of exciting. So check it out if you're interested in that. They have startup procedures, which you can put malicious code into or add yourself. You can backdoor CLRs and things. I'll touch on that, et cetera, or just collect credentials, which can be handy. Let's see. Also, a while back, a great contributor who's on my list, and his name escapes me at the moment, so I apologize. This was a pull request. This isn't something I wrote, but it's fantastic. It basically will go, if you're on the local server, it will can auto escalate itself to the service account, which will have sysadmin privileges, and it can dump all the password hashes, which then for SQL Server logons that you can then take offline with something like Hashcat and crack. And it's actually pretty common for SQL Server admins who manage hundreds of systems to, once they deploy a new instance, they install or create a new login that has sysadmin privileges that shares the password kind of across the entire environment. It's becoming less common now that people are kind of leaning more on Active Directory accounts, but it still happens at a semi-regular cadence. So very neat thing. So big thanks for that one. All right, CLR stuff. I kind of talked about this briefly. This is the high-level attack process for basically reverse engineering and backdooring a .NET assembly that someone's created. I have excruciating detail in my blog I did a while back on this, so that's on the wiki. But the high-level idea is we list the assemblies, and then we export them. So what this screenshot is basically showing is it's going to search through each of the databases. It's going to go through, look for different assemblies, and if it can find them, it's going to export them out by database name. You'll kind of create a folder structure that says CLR, exports, database name, and then, server instance, database name, and then the files. So all of these I randomly generated with that function I described earlier. So you can see the assembly names, the class names, methods are all randomized. When you finally get those out, when it's done running through its process, you'll actually see these in the output directory. So these are .NET DLLs that have been exported. And from there, you can then decompile them, .NET's managed code language. So it's pretty easy to get back to something similar, if not on the money for the original code. There's a lot of tools out there. I've become really fond of dnSpy because it allows some hot patching. So we can literally look at this, we can modify it, and then we can save it as a new assembly without, a real compiler. So it does kind of like hot IL patching, which is pretty sweet. So I don't know the dev of dnSpy, but thank you for all your hard work. If you're out there listening somewhere, it's another open source project. So this is a completely, free option. Also here, one thing, if you're going to be re-importing the DLL to overwrite something that's already in SQL Server, be very, very, very careful. Hopefully you're doing it in a dev environment as opposed to prod if you're not sure what you're doing. But if you do it, you will have to change or modify the MVID. So every time you compile, it creates this kind of like GUID that shows, hey, this was a unique compile, so that if someone's trying to re-import it into SQL Server, it doesn't import the same thing, I guess. So it's supposed to be unique. Anyways, you'll have to change that in order to do a successful alter statement that will allow you to overwrite what's there. All right, that's kind of the CLR high-level summary. I think that's enough to give you a general idea of backdooring a .NET DLL. Once again, check out the blog for more. Like I said earlier, another thing we worked on a little bit this year was kind of just roughing out a C2 framework completely based on SQL Server. So if we look at the diagram over here, maybe I'll take a step back. A lot of people are starting to do SQL Server development in the cloud. And so you can create SQL Server instances in Azure. And when you do that, it creates them off of databases, I think database windows.net. And so many people are poking holes through their WAFs or firewalls, whatever, so that they can have their SQL Server clients connect directly to the Azure instance on port 1433. And so as an attacker, we can leverage that as an outbound channel as well, if it's not being restricted to an IP or subnet, right? So the way I wrote this is basically you start up an SQL Server Azure instance. You run a little script that installs a database. It's literally just kind of a standalone database. that the attacker would do, right? And you spin this up and connect. And then you have two agents that you could then run on your target systems that you want to maintain access to. The first one can run on any Windows workstation. It is a scheduled task, or WMI trigger. I'm using the wrong phrase there, but just forgive my weak vernacular. Basically, it will run as one of those mediums. It will run a PowerShell command, and that PowerShell command will basically make a straight database connection out here, where the attacker can drop commands to run on this server. So we'll check in, say, give me some commands, and we'll run them as they come in. There's a second agent that's slightly different. So you can still use the main PowerShell script to install it, but it's going to install an agent job, which, like I said before, is an SQL Server scheduled task, sort of. And then it will create a persistent SQL Server link out to the Azure server. And so everything on this kind of second model lives on the database layer. It doesn't live on the OS layer in the more traditional sense. So it's kind of a neat way to get out and avoid detection. So it's just things to be aware of. The kind of blog goes into detection recommendations as well. It was posted a few months ago. I am kind of eventually going to be moving towards a custom CLR as opposed to simple command running. So there'll be hopefully a C# kit. The alpha version I released for Blackhat just has some basic stuff in it. The ability to run a query as a current user, if you install it right, and run it as the service account. So basically run as a sysadmin on the fly. You can run commands through the standard CLR method or via WMI, write to a file, basic file stuff. And then if you're moving, sensitive data back and forth or something like that, encrypting and decrypting with AES-256 with a provided key on both ends. So it's at least a starting point. Eventually, there'll be other kind of more common toolkits or common functionality baked in there. So here's some basic screenshots. Installing it on Azure, you essentially are going to point your instance in Azure that you can see here. You're going to provide it the database name you want to install it with, and then the username and password for that Azure instance, which you should have after the setup. You then install the agent. So this is basically the scheduled task version, I think. Let me see here. Oh, so the command that was my mistake. The command shows installing the PowerShell agent up here, but the screenshot's actually the server link. So in this case, we're saying go to this SQL server and install a link going outbound. So it has a few additional parameters, but all like the other functions include the verbose flag, and will give you insight on to kind of what's happening. In this case, adding an agent job with a link that goes outbound to SQL Server C21 database.windows.net. All right, and then as an attacker then from the internet, you're basically just running a query against the Azure instance, getting a list of your agents that are there. You can provide commands to it, like who am I, and then when they check in, the agents check in, they'll run the command, then you can get the results back and get a general idea kind of when that occurred. So it's pretty bare bones right now, but it's enough to kind of prove out the general concept, so people are at least kind of aware of the potential risks there. All right, data targeting. When people think about databases, they think about data targeting. So this is a very popular, couple slides. It's pretty basic though. One of the most common methods is to basically inventory all the databases and just look for really big database files. It's not always going to be guarantee sensitive data, but it indicates at least where data is, and that can be a good starting point. The next is SQL Server supports transparent encryption, which means people can, certain databases accounts can connect, get data, and it's encrypted on disk, but to the user's eye, they don't have to see that. It's automatically decrypted for them. And so people use transparent encryption a lot on SQL Server when they need to meet compliance requirements. That's kind of the most common scenario. So HR data, credit card data, things like that, to make sure it's encrypted on disk. So when you're getting that inventory of databases, highlighting that, people tend to, people tend to encrypt stuff they care about. So if it's not encrypted, it's maybe in some environments, it's less likely to be sensitive, but if you see the flag there, it's encrypted for a reason, so go check it out. It's worth noting that sysadmins by default will be able to decrypt that, so you can log in as a sysadmin, and you should be able to query all the data transparently, quote unquote. Also, once you inventory the data, tables, etc., you can search columns with keywords and do some basic data sample. So this is something actually, it was like the first Metasploit module I wrote, but it was based on work done by DigiNinja. His name escapes me at the moment. I think he's out in the UK. But yeah, basically doing a search for keywords, which can be very, very effective, looking for kind of regulated data and non-regulated spaces of the network, so it can be used for auditing pretty well. And then I added a little switch so you can check if it's actually cardholder data based on the Lund formula. So here are some commands: database size, whether it's encrypted, searching for data by keyword. You can check these out offline. The deck will be posted to the wiki as well. I'll give you a really quick demo here. Import PowerUpSQL. We're going to run SQL instance domain. So it's going to get that list of SQL servers from the domain. It's going to attempt to log into each. And then it's going to sample the data. Oops, I'll just run it again here. That's fine. Give it a moment. There we go. So threaded means, you can run a couple things at once, a couple servers at once. It's not the queries that are threaded, it's the servers. But it's going to get 2 rows from each server. We're going to look for credit, card, and password for keywords. We're not going to try to query default databases like master and things like that. So the output, computer name, the instance, database schema, table, column, and then a little sample here, so you know that it's real, because sometimes, especially when you're looking for things that aren't credit card data, you can get some funny things. One thing to note with this approach is naturally, if you have DBA privileges, you're going to have a lot more success pulling data. If you have least privilege user, the likelihood of you getting really sensitive data is lower. So keep that in mind. If you've got a DA, add yourself to the DBA groups and then run that, or impersonate a DBA before running that. All right, data exfiltration. I haven't spent a ton of time on data exfiltration functions, hopefully for obvious reasons. At some point, I'll probably get down to that. Obviously, the SQLC2 has some baseline capabilities, but you can go through common TCP, UDP protocols, SMB, etc. Short list here: HTTP, SMTP. There's native mail function in SQL Server. You can use OLE automation objects or any of the other supported programming languages to make HTTP requests with data. DNS tunneling is common, SMB, ICMP, which I don't have here, and then the links we saw in kind of that demo. So that's it. That's kind of the idea behind PowerUpSQL. It's a tool for attacking SQL servers and finding data, but also trying to escalate privileges in Active Directory environments. I will just go back here. If you have any questions, feel free to reach out on Twitter. Check out the blogs at NetSpy. We'll try to keep putting out information there. The wiki we talked about later, and then you can download the tool from github.com/netspy/PowerUpSQL. Thanks everyone for your time.